Hello, this is our entry for the competition, which is SYGHTsense, our product. It is a low-cost assistive technology for the visually impaired. Most SYGHTsense features, going through them one by one, we have the navigation and localization for indoor and outdoor. Our see and read, which is our machine vision module, which has obstacle avoidance, object recognition, and voice assistance. We have our emergency and safety features, which is our emergency call, our phone app, which utilizes Flutter, voice control, chatbot, and text-to-speech capabilities. If you want more detailed charts, you can use the QR code.
The first feature is the chatbot. This is the layout of the chatbot. We have responsive UI, and we actually implemented the logo that we have designed for SYGHTsense. Coming up next is the video demonstration of it. The problem with our group is that we are not subscribing any plan provided by OpenAI. Therefore, we actually exceeded the quota when we are developing the chatbot. But yeah, when the reset time comes, the thing will work. Okay, next up for indoor navigation, we considered using indoor Wi-Fi positioning, but we found out the MAC address, which is the 80 point of the Wi-Fi throughout the entire uni when we walk around from different blocks and to different levels are the same. Therefore, we went into using AR navigation in the phone. This video is navigating the user from one of the lifts in our uni to one of the auditorium. The video utilizes pink cubes to show the user the navigation line, the path line. So the user follow the cube and walk around in a 3D map projected in their phone. And along the way, there will be assistive audio to provide navigation guide. This is the 3D projection of our auditorium, and it is over where the green cube ends. We are arriving the door, and if we close the map and go to the phone's camera, we are seeing the auditorium door.
Moving on to the see and read portion of the system. So as you can see here, we have utilized the Google dataset, which is a pre-trained dataset, where it will be pumped into OpenCV to serve as a bridge for the Google dataset to be loaded, and to the Python, where it will be processed with the Raspberry Pi and executed through the Raspberry Pi camera. So in the Google dataset, there is 80 object classes. So moving on to the object avoidance, the algorithm for this portion will be developed through Python also, and then implemented through Raspberry Pi, and will be injected out to the ultrasonic sensor with the buzzer. So for the ultrasonic sensor, it will echo a back and forth signal, where the time will be calculated between the sending and receiving of the echoes, and the distance will be successfully calculated, and it will act like a car sensor. So as you move nearer between the ultra sensor with the object, the frequency of the buzz will increase. So after testing, we found out that 40 centimeters between the ultrasonic sensor and an object would be the safest distance for the user to be informed. So over here, you can see an example of the algorithms being executed. On the top left, as you can see, the camera was able to determine that there is a TV and a keyboard, and we place it to look at it. And moving on the bottom right, you can see that the ultrasonic sensor and the buzzer is censoring the distance between the object and the ultrasonic sensor.
So the SYGHTsense auto navigation using Mapbox has two features. Where the first feature is the user can preset a home location, and then when he push the go home button, it will take him to their homes. But the second features, when the users press a button, it will record the voice and then navigate to the desired location. But currently it's not done yet. So now we'll show the first features. Okay, that's all for the auto navigation.
So looking at the Flutter phone app, so it is a straightforward design for with a shallow learning curve for the blind assisted persons. Looking at the video, you can enter the map, enter the app, which is easy to navigate, and each button has a text-to-speech capability, so it will let the persons know which page they will be at. The Where Am I button, obviously, will do that feature, and each button leads to the other features being implemented currently. You see the emergency and safety features that was developed. It's a hold button, so it will stop the user from accidentally pressing the button. So therefore, you need to hold, and it will call the emergency services immediately. It's a large button, which is easy to access, and the page also has a Where Am I feature to let the user know.
Alright, that's all about us, SYGHTsense.